Hello everyone, I welcome back to NEET WORLD. So I hope you are watching these live sessions regularly here. Okay, so in the last sessions we have covered disproportionation reactions. What we covered? From redox reactions we have covered disproportionation reactions. So now tell me, what do we mean by disproportionation reaction? The same element will undergo both oxidation and reduction simultaneously right now. So tell me, here one example that we have discussed is like H2O2 we have taken. So it will be giving you water plus oxygen. So what you are seeing here, so -1 oxidation state of this oxygen will be converting into -2 here and 0 here. So it means what is happening here, the same element oxygen is undergoing reduction as well as oxidation. Okay, what is this reaction called now? Disproportionation reaction. Now what if the reaction is taking place in backward? It means from these two different oxidation states, oxygen is in -2, 0 now. Now it is converting from here to here. So what you can say, if the reaction is reversed, then you can say this is a comproportionation reaction. So from here to here you can say this is disproportionation and reverse of that is comproportionation, right? Right. So this is what we discussed in the last class. And these are some examples, you must know these examples for disproportionation reactions, okay, that we discussed in the last class, because there will be effect of concentration, like dilute NaOH if you take, you will get halide ion and hypohalate ion. Okay, if you take concentrated you will get halide ion and the next halate ion, like +5 oxidation state in this case and -1 here, 0 here, and this is 0 here, -1 here, +1, like the different oxidation state containing products are formed by taking different concentrations of bases here, OH minus. Okay, next comproportionation is done. Next today we will be discussing about balancing of redox reactions. Just before going to that, just solve these questions, basic questions related to this redox reactions from JEE, NEET and EAPCET. So just tell me, what is the change in oxidation number here? What is the change in oxidation state here? Carbon, here it is, what is the oxidation state in this case? So here it is -4 and here it is +4. So from where to where it is converting? -4 to +4. So which option is correct for that? Second option. Okay, then next tell me, what about the next question? See here they are saying in the neutral or faintly alkaline medium, KMnO4 KMnO4 oxidize iodide ion into iodate ion. So from where to where? Iodide to iodate. It means, what is the formula of iodate? Means IO3 minus. Okay, you need to know the formulas here. Okay, so for this question they are saying KMnO4. Okay, you know guys, here KMnO4 in different mediums it will show different oxidation states. So when I take KMnO4 in acidic medium, basic medium, neutral medium, in acidic and basic, this is basic, instead we am calling it here it as slightly acidic or neutral. What I am saying, this is slightly acidic or neutral, and last one is completely strong basic medium I am taking. Okay, so when it is in acid, like KMnO4 +7 oxidation state in acidic medium converts into Mn+2 ion. How it will be? Mn+2. Now KMnO4 in neutral medium it will be converts into Mn+4, and in strongly basic medium +6. Now what is the N factor in each case? Here it is 7 to 5, 7 to 2 means 5. And here 7 to 4 means 3, and here 7 to 6 means N factor is 1. Okay, it means whatever may be the other compound reacting with KMnO4, if this medium is acidic, the KMnO4 will be forming +2 oxidized like reduced compound, like +7 to +2 compound. Okay, like that, depending upon the medium we are using, N factor. What do we mean by N factor here? So +7 is converting into +2 means how many electrons it is gained? Number is reduced now, the positive charge is decreasing here. So it means we are adding some negative particles. So what is that? Electrons only. How many electrons added? 5 electrons, like that. Okay, here 3, here 1, that's it. So now look at here, in neutral or faintly alkaline medium, KMnO4 oxidize. Iodide ion to iodide ion. Change in oxidation number of manganese in this reaction. What is the oxidation state number change in this reaction? Tell me. Huh? +7 to +4, right? Next. What about this question? Which of the following is not a redox reaction? Which is not a redox reaction? Tell me.
Which charge will be there on
SO4. See, SO4, it will be 2 minus like this, or instead you can write Na2SO4. Both of them are same only here. Okay. So now what is the oxidation state of sulfur here? Take X and calculate X plus 4 into -2 for each oxygen, and what is the total charge on here? -2. Take here -2. So it will be 6. Like this you can calculate oxidation state that we discussed in the last class. Now tell me here what happening? Barium chloride treated with sodium sulfate. What is the compound formed? Here it is forming barium sulfate and sodium chloride. So what is the oxidation state changed here? Barium is being barium +2 only in both cases, means no change. Sulfate being as it is, it means, can I say this is a redox reaction? How it is? It will not be, because redox means it should involve oxidation reduction process. It is just a displacement reaction. See, these chloride ions are displaced here like this. Okay, so this is not a redox. Next, what about this one? So here zinc 0 converting into zinc sulfate means +2. Copper +2 converting into copper 0. It means what is happening? See, oxidation, reduction, both involving now. So second is the example of redox reaction. Now next, what about these two reactions? See here, chlorine is in +5 oxidation state. Okay, chlorine is in +5 oxidation state. What they are asking, not a redox reaction. Okay, so second one is a redox reaction and third one is also redox reaction. See, chloride here +5 forming 0 means what is that? Reduction. So 0 is converting into +5. This is what? Oxidation for iodine. Okay, so it means this is also a redox reaction, both oxidation reduction. Next here 0 0 converting into +1 -1. So one hydrogen atom is hydrogen is undergoing oxidation, chlorine is undergoing reduction. So you can say this is a redox reaction. So 2, 3, 4 are redox reaction. They are asking about not. So first option is your answer for this question. Okay, right. Next one. Tell me here, what are their oxidation states and how it is given for decreasing order of oxidation numbers. The correct order of nitrogen compound in its decreasing order of oxidation states. From higher to lower, tell me. Huh? So how much here it is? +5. How much here? Ammonium chloride means. So how do you check here? So ammonium chloride means chloride ion, ammonium ion with positive charge. So here nitrogen, 4 hydrogens are there. So 4 -1 if you take, this +1 if you remove, nitrogen will be with -3 oxidation state. Okay, so that should be the least here, because minimum oxidation state possible for nitrogen is -3. So least ammonium chloride is only in this option. Okay, it means definitely option 3 will be our perfect answer, because here you check nitric acid will be +5, nitric like here nitric oxide will be +2, nitrogen 0, here -3. So third option. Okay, so these are very basic questions that you should not do any mistakes. Next, here we have a balancing of redox reaction. So So how do you balance this equation, tell me? So first of all, write the skeletal equation. Yes, whatever they have mentioned, write it as it is. MnO4 minus C2O4 2 minus plus H plus giving rise to Mn plus 2 plus CO2 plus H2. Now what to do here? What is the oxidation state? Just assign the individual oxidation states of elements here. Plus 7, plus 3, plus 2, plus 4, like this. Okay, after assigning, what to do? Just check how many electrons are changed here. So during a chemical reaction, during a redox reaction, the number of electrons lost in oxidation should be equals to number of electrons gained in the reduction. So what is happening from here to here? Reduction. What is happening? Reduction. How many electrons are participating? 5. And what about this case? Plus 3 is converting into 4, means 1 electron is lost. How many carbons are there? 2. So for 1 carbon it is 1 electron. 2 carbons are there here, so 2 electrons. So you can write 1 electron for each carbon, there are 2 carbons, so 2 electrons are involved. See, here it is 5 electrons, here it is 2 electrons. Are the numbers are equal? Electron numbers are equal? No. The last electrons here should be same as that of gained electron in the reduction. So for making that, so just multiply this reduction equation with 5 and oxidation equation with 2. So that we will get, what we will get here, you are multiplying this reduced equation with 2. So that 2 MnO4 minus, and this equation with which number you are multiplying? 5. So 5 C2O4 2 minus plus H plus, that gives 2 Mn plus 2 plus 5 here. So 5 CO2 plus H2O, like this I am writing. Now just check, is everything is correct here? How many electrons are there? 10 electrons in the gaining in the reduction process and 10 electron losing in the oxidation process. So it is perfectly matching. Now electrons are perfectly matching now. Now what about the number of manganese atoms at right hand side here, this side, left hand side? 2. Left hand side also, right hand side also 2. It means both LHS, RHS should have equal number of atoms. Okay. So now here it is 2, here also 2. Next, what about carbons here? 5 2s are 10. Here only 5 you are writing. So it means you just multiply that with 2 because 5 2s are 10 now. So here also you can make 10 CO2s. So plus 10 CO2s. Next, what about that? See, what we are doing, balancing all the other atoms except oxygen and hydrogen. So manganese is balanced, carbon is balanced, done. Next, now balance oxygen atoms. Wherever it is deficient, that side you add water to balance the oxygen atoms. So how many oxygens are there here? 5 4s are 20 this side. And what about this? 5 4s are 20 here also. Okay. And what about here? 4 2s are 8. So total how many oxygens are there here? See, these are 8, these are 20, 28 are there. That side how many are there? 10 here, 2. So 10 means 20 only you have. So it means still how many oxygens are required?
8 oxygens.
Where it is required? Product side. Okay, there you add 8 water molecules. How many water molecules? 8 water molecules. That's it. Now oxygens balanced. What next here? Protons. So H plus ions here you can see 16 are there, here only 1. So you can make here 16, that's it. 16 H plus ion. Now what are the coefficients here you got from that class, like balancing the equation? For manganate, like permanganate you got 2, for oxalate ions you got 5. So 2, 5,
16.
Hydrogens are coefficients of the reactants. So here it is 16. So option 2 is your answer for the question. Okay, right, is this clear? Next, can you balance one more equation if I give you? I will give you one redox reaction equation. Before that, just tell me what are your answers for this thing. Just tell me your answer for this. What is the correct answer? Which of the following reactions are disproportionation? Tell me.
Sir, E is not a disproportionation.
See, what we know, same element should undergo both oxidation and reduction. See here, reactant plus 1 oxidation state for copper, here plus 2 and 0. It means yes, this is disproportionation only, no? Plus 1, 2, plus 2 and 0. It means disproportionation. Next here, it is in plus 6 oxidation state, forming here plus 7, here it is plus 4. First of all, we need to know the calculation of oxidation state. Very basic formula you can use and do that. Okay, this is also a disproportionation reaction. Next, what about here? This is already plus 7 manganese. Whenever species is in maximum oxidation state, it is not possible for it to go disproportionation, because see, here it is plus 7, here one should be greater than plus 7, one should be less than plus 7. But here both of them are plus 6 and plus 4, both of them are lower than this plus 7. So it means this is not a, it is not a disproportionation, it is just a reduction process. What is that? It is just a reduction reaction, not even oxidation also, just a reduction. Next, what about this? See, Mn plus 7, here Mn plus 2 converting into Mn plus 4. These two different oxidation states are forming only single oxidized product, like single oxidation state product. So it is an example of comproportionation, not a disproportionation. So what are the options here? Only AB. So where do we have only AB? First. That is your answer for the question, right? Next. Reaction, which reaction is not a redox reaction? Tell me here again. This is already we did this. Okay. We did this, yes. So the next one is here. If I give you a question, first of all, I will explain this question, but just tell me what is your balanced equation. Just take this equation and tell me what is your balanced equation. Otherwise, yes, just tell me answer for this question. Otherwise, so how do we do? What they are saying, 15 ml of aqueous solution of ferrous sulfite, ferrous plus 2, ferrous plus 2 ions in acidic medium completely reacted with 20 ml of 0.03 molar aqueous solution of chromate. What is the molarity of this Fe plus 2 ion? How do you do this? How do we do this? See what they are saying, 15 ml of Fe plus 2 aqueous solution in acidic medium is reacting with 20 ml of 0.03 mole of aqueous solution of dichromate Cr2O7 2 minus. Okay. Now what is the molarity of this Fe plus 2 ion they are asking. Okay. So for this you don't need even balanced equation also, you can directly do this. Okay, but you need to know what are the oxidation state it is forming after this reaction. So plus 2 ion will undergo, see dichromate now. So what is the oxidation state of chromium here? Plus 6. Okay. So chromium already it's in is it in maximum oxidation state. So chromium oxidation state maximum possibility is for plus 6 only. Beyond that it is not possible. So it can only undergo reduction now. So it act as a oxidizing agent. What I am saying? Oxidizing agent, and oxidizes other species, reduces itself. So it will be Fe Cr plus 3. Okay. Now what about Fe? It get oxidized. So it get oxidized means you can say this is a reducing agent. So now it will be giving you Fe plus 3 like this. Okay. So now I have explained you about law of equivalence when we are discussing about mole concept also. So using that you can easily explain this. So what do we mean by law of equivalence? See, there is reducing agent, there is oxidizing agents. No? So number of equivalents of reducing agent and oxidizing agents are equal. Oxidizing agent, that's it. By taking this, so you have a normality formula that gives number of equivalents by volume, that should be in liters. Next, number of equivalent means what you will write here, N into V. Okay, just send this V here. Okay, so now why we are doing this? Because they have given in molarities and volumes. So that's why I am taking this formula. Now in the place of normality, I can write, see, molarity into valency factor, that is equals to normality. So wherever I have N, I can write this thing. So molarity into N factor into volume can be written wherever we have number of equivalents. So now in the place of number of equivalents of reducing agents, you can write N into NF into V. Okay, this side also N into NF into V. Okay, like this we can make. Okay, now tell me what happens here. So N into NF, what is M here value? So what is the reducing agent? Iron. So what is its volume they have, what is the data they have mentioned? 15 ml. So volume is 15 ml, and what about its N factor? See, plus 2 is converting into 3. It means how many electrons involved? 1. And they are asking molarity of this ion. So M they are asking. Now this side what we have? Molarity. How much for dichromate they mentioned? 0.03. And what about its N factor? See, plus 6 is converting into 3, means N factor is 3 for 1 chromium. Like that, how many are there? 2 are there. So total N factor will be how much? So you should take here 6. Okay, into, and what about volume mentioned? 20. How much volume it is? 20. So the next, now whatever the value you get, that will be your answer for the question. Okay, so now this will be how many times? 5 3s are 5 4s are. So this is 3 1s are 0.01 here. So you can say 24 into 10 power minus 2. So what is your molarity for this? 24 into 10 power minus 2. They are mentioning it as dash into 10 power minus 2. So that value is how much now? 24. This is how you need to calculate the things. Okay. Now I will be giving you one question in a similar way. Just tell me number of moles of oxalate ion C2O4 2 minus is oxidized by 0.1 molar KMnO4 of 30 ml of how much value? 0.1 molar of KMnO4 of 30 ml. So using this KMnO4, how many moles of oxalate ions can be oxidized? Yes, tell me fast. Do it in the same way. No issues, just try, I will help. Got the answer? Yeah, look at here, very easy. Again, I will give you one more question after this. Listen here. So now what I have given here, KMnO4 and then next oxalate ion C2O4 2 minus. Okay, now what happens here? So KMnO4 will convert into Mn plus 2, okay, and then next here oxalate ion will be converted into CO2. That is what we did during the redox reaction also. Okay, so now what happens here? You can use what? Law of equivalence. So this is oxidizing agent, equivalence of oxidizing agent and equivalence of this reducing agent. You can take here, and now what is the data they have provided? Number of moles of oxalate ion is oxidized by KMnO4. So it means one side they have given normalities, I mean molarity and volume, another side they are asking number of moles. Now what is the relation we got? Wherever we have law of equivalence like this, you can write here m into n factor into volume. If this is in ml, you just divide here with 1000, okay, and another side you can write n, like whenever we have law of equivalence here, like equivalence, number of equivalence, that you can write n into n factor. What you can write? N into n factor. So here you can write n into n factor of reducing agent. So what is our reducing agent here? See, this oxalate ion is undergoing oxidation and reducing the other. So what is the n factor for this? See, 3 is converting into 4. It means 1 for 1 carbon, there are 2 carbons. So 2, n factor is 2. They are asking number of moles. So you need to calculate this n. Okay, you got here 2. You need to calculate this n. What about this side? What is the molarity they have mentioned? 0.1. Okay, and what is the n factor of KMnO4? Plus 7 is converting into 2. It means what is the number changed? 5. So you can take here 5. And the next, what about volume? 30 ml. See, if it is mentioned in liters, do not take here 1000 in the denominator. Since they mentioned in ml, so you can divide this with, so it will be 0 removed. The next what you have here, so you have 5 means 2.5 I can write into 10 power minus 3. So what is the n, like number of moles of oxalate ion will be getting oxidized here. So number of moles of C2O4 get oxidized is 2.5 into 10 power minus 3. How we got this number? Just see, here 100 is there, here 10 power minus 1 is there. So we can write 10 power minus 3. So here 5 by 2 is there, so it means 2.5, that's it. Okay. So in the same manner, just tell me what will be the answer for this. Number of moles of KMnO4 required to oxidize 2 moles of ferrous oxalate FeC2O4, okay, in acidic medium. Giving the hint also, in acidic medium. So tell me, how can you solve this? Yes, how can you solve this? Tell me what is your answer for the question. Yes, in the chat box, those who are in the live session can answer me this question. Yes. So how can you do this? Very easy it is also. Number of moles of KMnO4 required to oxidize 2 moles of ferrous oxalate. So it means here ferrous oxalate. What we know? Ferrous, it means +2, iron is in +2 and carbon is in +3. We are treating this with KMnO4. Okay. So it is +7. Now it will be converted into acidic medium now. So definitely manganese undergoes reduction and forms Mn+2. So iron is in +2 converting into +3, Fe +3. And what about carbon here? +4. Like this it is happening. Okay, right. Now tell me what is happening if you observe here, manganese is undergoing reduction. Okay, and what is the N factor involved in this? Number of electrons involved is +7 to +2 means 5. What about iron here? Iron is undergoing oxidation. Along with that, carbon is also undergoing oxidation. So what are the things involving in the oxidation? Carbon and iron. Okay. So now what is the N factor involved in iron case? +2 is converting into 3 means N factor is 1, and carbon in this case N factor will be 2, because for 1 carbon it is 1, 2 carbons are there 2. Okay. So now total oxidation, N factor involved in oxidation is how much? Total N factor in oxidation is how much? Here it is 1, here it is 2. So total it will be 3. In the oxidation, the total N factor, number of electrons lost in oxidation is how many? 3, right? That one you need to consider as N factor of this ferrous oxalate. Okay. So now equivalence of number of equivalents of KMnO4 and number of equivalents of ferrous oxalate FeC2O4. Okay. Now what to do here? N into, see what they are asking, number of moles of KMnO4 required to oxidize 2 moles. They are talking in terms of moles only now. So both sides, wherever you have number of equivalents, you can just write it as N into N factor. What you can write? N into N factor. This side also you can write N into N factor. So now what happens? How many moles they are asking? Yes, they are asking about number of moles of KMnO4. What is the N factor for KMnO4? 5. Now what about the ferrous oxalate? Huh? How many electrons are moles are involving here? 2 moles. N factor is 3. That's it. So number of moles of KMnO4 will get involved in the reaction is 6/5. Okay. So this will be your answer for the question. 1.2. Okay. 1.2 moles of KMnO4 get involved in the reaction. Is this clear? No? Yes. So now you got all these models related to number of equivalents also. Okay, right. Now you know KMnO4 can be used as a self indicator. Why I am saying self indicator? During the reaction, what is the color of KMnO4 here? Purple here. Okay, purple. But when it is converting from +7 to +2, what is happening? Due to oxidation number change, here it is colorless. What I am saying here it is colorless. So colorless it does not have any color. It means at the beginning of the reaction, what is the color you are seeing? Purple. As reaction is taking place, the intensity of purple color will get decreased. Why it is decreasing? Because KMnO4 is consumed during the reaction. It is reacting with this. So whatever the reactant initial is there,
that compound gets disappeared.
Slowly it will get disappeared. It means consumed. That will be converting into +2 form. So due to that reason, the purple color of this KMnO4 will get disappeared slowly. Okay. So that's why we are saying this is a considered as self indicator. Okay, right. Next, one more thing here. What is the reason? Now you might get that, sir, what makes it to be the color in its +7 oxidation state, and why it is not having any color in Mn+2? Because here Mn+7 now, so here it is in +7 oxidation state now, so d orbital is empty. All d orbitals and valency orbitals are empty for manganese. but here oxygen is there, no, that is in oxide, -2 oxidation state. So now what happens is, this is small size now oxygen, and on it 2 electrons are there extra. So now due to this small size and high electron density, now oxide will donate its, share this charge with this negative charges with manganese. Now what you can say, charge is getting transferred from oxide ion to manganese ion. So you can say simply, you can consider this as a ligand. What I am saying, the word ligand, from this ligand to this metal, charge is getting transferred. So due to that charge transfer, this KMnO4 is showing color. What is the reason behind the color of this KMnO4? Charge transfer from where to where? Ligand to that means oxygen to oxide ion to manganese. So from ligand to metal, charge is getting transferred. Okay, that is the reason. But here there is no such thing. So here only already d orbitals are having electrons, d5. All of them are half filled. Okay, so there is no such kind of phenomena taking place. Okay, that's why it is colorless. Okay, right. Is this clear? Right. One more thing. Can you answer this? Hey, read the question once. What they are asking, in the titration of KMnO4 and oxalic acid, it means that oxalate ion we have taken now. Oxalic acid is nothing but H2C2O4. This formula you should remember here. So that is nothing but oxalate ion you can take here. Okay. So with KMnO4. Okay, what they are saying, in acidic medium, the change in oxidation number of carbon at the end point. What is the change in oxidation number for carbon from this oxalic acid? Change. So it is converting from +3 to so change in oxidation number is how much? Change in oxidation number is here +3, here it is +4. Okay, so you don't, they are not asking number of electrons, they are just asking oxidation number change. Okay, 1. Okay, then next, this is done. Okay, next question. Okay, let me give you one more question. So just to balance this equation, Cr2O7 2 minus plus C2O4 2 minus in acidic medium converting into Cr +3 and CO2. Balance this equation fast. Got the answer? What to do first? Assign their oxidation states. What are the oxidation states here? And here, here plus 4, here I already given it is plus 3. So now how many electrons are involving in this process? 2 chromiums are there, each one is converting from plus 6 to plus 3, means 3 electrons. For 2 chromiums it will be so tell me 6 electrons. Now what about this? 2 carbons, each carbon is plus 3 to plus 4 means 1 electron. So it will be like that. So after that, are they same? Number of electrons gained and lost are same or different? Here it is different. So here you just take this as it is, this reduction equation as it is, but oxidation equation multiply with 3. Okay, therefore number of electrons becomes equal in both cases. So you can write Cr2O7 2 minus plus C2O4 2 minus plus H plus converting into Cr plus 3 plus CO2. Okay, like this we have. So what I told you, this equation remaining as it is. So here 1, here also 1, but how many chromiums are there here? 2, so you can take here 2. Okay, right. Now carbon is how many carbons here? 2 carbons are there, we are multiplying with 3. So it means here it becomes 3 C2O4, here it is 3 multiplied with 3, but how many carbons are there here in one molecule? So it is 2 3 is 6, now you can write here 6. Okay, and after that what to do? Now number of electrons lost and gained are equal. Now what to do, tell me? Chromiums are balanced, carbons are also balanced. Just check, 2 chromiums, 2 chromiums, 6 carbons, 6 carbons. Next what to do? Oxygens. How many are there here? 7 plus 12. Okay, how many are there? 12. Okay, that side only 12 are there. So you just add plus 7 water molecules you add. Wherever oxygen is deficient, there you add water. So now everything is balanced, oxygens, chromiums, carbons, everything is balanced except hydrogens. Now what to do? How many hydrogens are extra here? 14 H plus ions are more. It means you add that 14 H plus ions this side. So Cr2O7 minus 2 plus 3 C2O4 2 minus plus 14 H plus gives rise to 2 Cr plus 3 plus 6 CO2 plus 7 H2. That's it. This is your balanced equation. Okay, right. Is this clear? That's it. Okay. So the remaining parts of this redox reaction we will discuss in the upcoming session. Okay. So next class we will be having discussion on the remaining parts. What are the like balancing the redox reaction in basic medium. Okay, and also for disproportionation reactions we need to discuss. Okay, so those are the 2 things, and if any other we will discuss in the upcoming session. Okay, right.